Hey there, C# friends. My name is Matthew. I'm the C# artisan, and this is the 13th video in my series on Azure Service Bus. And in this video, I'm actually issuing a correction or clarification. So a few of you noticed something that I did in the earlier videos, and you sent me comments and messages saying, hey, buddy, that really wasn't the right way to do that. And you all are correct. I made a mistake. And you know, when we make mistakes, we all do. There's nothing really for it except to take a deep breath, have a sip of coffee, and explain what you did wrong in order to do better. So that's what we're going to do today. And all of this has to do with the way that I was calling some async methods. So let me show you what I'm talking about. So here is a screen grab from one of the earlier videos. This is from Send and Receive. And what you can see I'm doing here is in the main method, we're simply creating a service bus client, creating a service bus sender, creating a message, and sending it. And the problem is right here with this wait. So we call send message async, which is an awaitable method. In other words, it's declared as async. It returns a task. And the idea is you should await it. And instead, I'm calling .wait. So the problem here is this is meant to be async, and I am forcing it to be synchronous by calling .wait. And this is really not the way to go. Here, there's another one. Let me show you another. This is a screen grab from a later video where I think I'm talking about how to receive and delete, different receive modes. Once again, we're creating a receiver, and here we call message equals receiver dot receive message async, passing in our default time, our timeout, and then dot result. And that's the problem right there. So receive message async, again, it's marked as async. You should await it. And instead, I'm forcing it to run synchronously by saying dot result. And here's another one, complete message async dot wait. So this dot wait, this result, and the dot wait in the first one, really, we shouldn't be doing that. So why did I do it? And what's the proper way to handle this? So what's going on is this demo is in just a console app. And the outermost method, the entry point to the entire application is here, static void main. And that is a synchronous method, which makes sense. You know, the Windows operating system, which is launching this little app, it doesn't understand C# tasks. Now, it does turn out that you can declare a main method as async. I actually didn't know that when I recorded these videos. I learned that later, and I'm going to show you that in a minute. That's a quick way to solve the problem if you're just building a console app. But the reality is all of your Azure Service Bus code is probably going to be hosted in an async call context. In other words, the method where you're going to create your sender and send the message, or the method where you're going to create your receiver and receive the message, it's probably an async method itself. And that allows you to just properly await these calls rather than doing this janky, forcing it to be synchronous just to cope with the fact that your call context is synchronous. So I'm going to just switch here to Visual Studio and show you a little bit of code that looks like this that is done in what really is the proper way. So here we are in Visual Studio, and what you're looking at is a little demo program that I put together that does a few different service bus processor operations. And the easiest way, I think, is let me just run it and give you a demo, and then we can do a code tour. So I'll build it and run it. And you can see, welcome to the Service Bus demo. and then you choose a menu option, 1 through 5. So let's choose menu option 1 to send a message. And it goes ahead and it sends this little weather report message. And then we can choose menu option 2 to receive that weather report. If we want to send 5 of them, we can choose option 3, and it's going to loop and send us 5 weather reports. And then we can receive the first one. There's the first one, should be 4 left. And you may have noticed we can start a service bus processor. So if I select item 4, it starts the service bus processor, which then immediately gets 1, 2, 3, 4 weather reports. And if I send it another weather report, it'll get sent and immediately get received. And last, option 5, to stop the service bus processor. So that's what the program does. And here's the code for it. And the first thing you'll notice is that my main method is marked as async. So this is a little bit of C# magic. And as I mentioned, I wasn't aware that you could do this, but it's pretty fascinating. And if you want to learn, kind of take a deeper dive into Async-Await and what's really happening here, and also what Async-Await actually does under the hood, why it's important and what's really going on, I've got a couple of videos called Async-Await that really kind of go deep into that. But for now, the main thing to understand is that our outermost call context is async. And so here in my little pattern matching switch statement, where I choose which method to run and then await it, I can await everything. And all of these methods, send a message, receive a message, send several messages, they are all async. So let's go look at send a message. That's in my sender. So what you can see is it's marked as async task send a message. And internally, it makes one of these weather reports, creates a service bus client, figures out which queue it's going to talk to, creates a service bus sender, sets up a message, and then here's the key point. We await sender.send message async, right? There's no silly send message async.wait, which forces it to be synchronous. We properly await it as we should. And the reason we can do that is that the calling method is marked as async. And the reason that works is that it is called in an async context itself. So we're async all the way up the chain. Let's look at the receiver. It looks the same. We've got async task receive a message. So we set up the client and the receiver, and then right here's the action where we receive message async and await that method rather than that dot result, which forced it to be synchronous. And again, when we complete it, we just await receiver dot complete message async. So this is the way your service bus code should look, where your calls are inside an async method and you are awaiting the asynchronous service bus calls. The last one to look at is just that service bus processor. So here we are starting the processor and it's async, and we just create our processor class, we wire up the event handlers, and here's the magic. We await processor.start processing async. And then when it comes time to shut it down, stop processor is also async. And it's a disposable, so we need to dispose of it. And look, we await stop processing async, and then we await the casting it as async disposable and calling dispose async. So there you have it. We are fully async. This is the proper way to write your service bus processor code. And I just want to say thank you to those of you who commented and pointed this out. And if any of you have a question or a comment or a correction, truly, I welcome your comments. I want to hear from you. So thank you very much. Hey there, C# friends. Are you enjoying these videos and finding them helpful? I hope so. And if you are, please go ahead and like the video on YouTube. If you haven't already, please subscribe to my channel and feel free to leave a comment. I would love to hear from you.